Welcome to the first talk of this morning after the breakfast break. My name is Selma Becker. I'm working with ING and I'll be talking about Hadoop security. Now, Hadoop security is a wide area and you could probably talk for days about it. I'll be focusing on some of the more interesting parts of our enterprise journey regarding Hadoop security, about things that we put in place and some pretty technical detail. You can also view it from a higher level point of view regarding risk assessment and these things. That's not so much my focus today, that will be for another talk. First, a few words about me. As you can easily guess by my accent, I'm originally from Germany. I live in the Netherlands now, and that happened so because back in 2011 I met a wonderful woman who is now my beautiful wife. This is us together in the Philippines. Well, this is my wife, this is a Python. And we moved together to Utrecht in the Netherlands, lived there with our family. Here you see me with the youngest member of our family, that's what we like to do. We like to travel. This photo was taken on the Pont du Gard, the ancient Roman water pipe near Nîmes in France, and it was just before the security again. The security guy told us that no, you're not allowed to walk your little boy on that stone ledge. Okay, but back to the subject. Hadoop security. I'm going to tell a little bit about Hadoop security, why and how, how then we came across the general question of Hadoop security and how to find a common language by identifying Hadoop usage patterns, how to look at Hadoop security and how to map different security items to our deployment patterns. And then I'm going to describe a little bit the outlook to what we are trying to do, which is I like to call it a shopping list model of building blocks for building your Hadoop security architecture in a modular way. I will cover a little bit what we did, what we learned from it, and what we are going to do the same way or in a different way in the future. The challenge. We are building a data lake in ING. So now data lake, that is a wonderful buzzword. It is the processing platform where all your data goes in and you can keep the original version of everything. Everything can be joined together, everything can be sliced and diced in a very dynamical way. And why are we doing this? We do this because we as a bank see that in an increasingly digital world, we need to understand our customer needs better. So that means we need to segment our customers better and better so that we can make them the best offers that are good for them. So we need to empower our data science teams to use the best and greatest tools to do that. That's one part of it. The other part is what in Dutch we call the moetjes. So that's something we have to do. We have to be very, very precise in doing our own reporting, our auditing for ourselves and also for the authorities. All this goes together in the data lake, which is a multi-technology architecture, but another thing that ING is at the forefront at is to use as many open source components as possible in this architecture, and Hadoop is at the core of this. Now, this brings with it a number of risks. You have all your data in one spot, so what happens if you screw up, you lose data? What happens if data leak out? Or what happens if a malicious intruder gets access? It can be expensive for us. It can have legal consequences, so we can be fined, or we can even face criminal prosecution in the worst case. We will risk our reputation if sensitive data leaks out, and all this needs to be prevented. So we have to be much more careful and much more precise than many other enterprises in this. Because we are a bank, and also because we actively want to rebuild trust after the financial crisis. Okay. So now enter Hadoop, and Hadoop has been around for 10 years, and even 5 years ago, everybody said, oh yeah, wonderful, we can just play with it, and you slam your Hadoop on your cluster, and in the default version, as you pull it out of the box or out of your tarball, there is no security at all. Okay, you have a concept of users and groups, but Hadoop doesn't check on it. So I can go to Hadoop and I can say, I'm Mickey Mouse. And Hadoop says, yeah, wonderful Mickey Mouse, here are your files. It does not care whether this user exists on an operating system level or on a directory level. It just accepts everything. And anybody could read or modify data in an unsecured Hadoop. So that doesn't work for us. Security design has to be built in, it has to be enabled, and that is what we did. We spent a whole lot of time and brain power and manpower on designing this into our Hadoop systems and on implementing it. Okay, let's go back about 1.5 to 2 years. Several teams in ING were using Hadoop. They had different use cases. There was recommendations there, fraud there, data batch processing over there. And we felt the need to exchange our best practices, learn from each other what we did good, what we could do better, and well, the marketing buzzword would be to leverage synergies. So to reuse stuff that we did well in one place and roll it out to other places as well. In order to do that, we brought together a community of several different countries within ING, and we identified so-called Hadoop usage patterns. So you say you have a use case, and then you want to match this use case to a pattern. And we found for now that we probably have 3 to 4 use patterns. And we tried to map these to the overall data lake architecture. This here is our data lake reference architecture. I affectionately refer to this as the picture with the many boxes. Well, okay, so to make it easy, here is where data comes in, here is where it gets processed, here is the control and governance, and here is where data gets out. So there are different technologies in here. Where do we use Hadoop? We have 4 different areas. We've got an incoming staging area where we keep a copy of all our original data, unprocessed, unmassaged. We call this the operational status area. You can think of it as an online archive, and we call it the use pattern for that, file storage. So basically, it is just something where you stash away a large amount of data and you don't do a lot of it. So that is use case 1. We found a second use case where you don't just stash away data, but you actually process those data within Hadoop. Why does this? Yeah. So we call this the deep data use case. So you run all kind of fancy algorithms, but you run them in an automated way. Then you've got analytical Hadoop, where you run stuff in an interactive way. So this is where your data scientists come in with their Python notebooks and stuff. And all these things are related. We also have a 4th use case, which is real-time processing, and we are currently looking at it. It might, however, be that we are not going to use Hadoop for that. Or maybe we use components that are within the Hadoop ecosystem. There's a lot of movement that I saw, especially here on this conference, about this. So what we have right now is we have a lot of teams that are doing this. We have one team that is very active building this part. And then we have the deep data pattern that we are going to build now, which brings all these things together because it's about operationalizing those interactive patterns into something that can run in an automated way. That has certain interesting security implications that I will come to in a moment. So what do you do security-wise when you have all these different boxes with data in them? Number 1 is, and that was our first approach that we implemented quite successfully, is perimeter level security. But you also have application level authentication and authorization. So that means you can go inside your cluster and each application knows who is allowed to do what and can check whether this is okay. You've got OS security, so you've got your Linux users and groups and file permission, and you've got data protection, which is things like data encryption, stashing them away. There's a lot of stuff that you can find in the internet about this. I will only deal with some of these parts today. You have to view security on a general as a 5-pillar model. I plagiarized this from Hortonworks because it's really quite good. You've got the 3 central components: authentication, that is, I have to prove who am I, it's like you have your ID. Authorization is, once I've proven who I am, then what am I allowed to do? And auditing, so that you can reproduce who did what. On top of that, you've got administration, so how do you get your security rules into the system, and you've got data protection on the lower level, which is basically, in that context, like damage control. Building blocks in that context. Okay, number 1 is perimeter security. This is what we did in the beginning. This is what the analytics guys still do almost exclusively today. It means you have a firewall nobody is allowed to go through. Nobody is gaining direct access to your computing cluster. You've got certain stepping stone or gateway servers. So we are currently using Citrix for that. So you cannot log in directly, you cannot copy-paste data. You have very, very small defined ingestion paths that could be a defined SFTP upload. We have our own company standard for file transfer, so we can get data into these analytics clusters. Typically, you are not allowed at all to get data out. If you do only this, you can have local users. What you want to do, however, on the long run is you want to align this user management with your corporate directory. And that becomes even more interesting with the other patterns that I'm going to talk about in a moment. One challenge about this model is you are not connected to the, or you have very limited connectivity to the outside world. Software updates, Python packages, and all that needs to be transported manually. It's quite a pain, but okay, it works. However, it does only work for those interactive things. If you do batch processing, if you have your data streams that bring in new data every day, transactions, customer data, and you want to process it in an automated way, then you need to have more defined connections, and that means you need stronger internal security. Also, when you come into these production systems, we have another paradigm where ING is quite in the forefront, which is continuous delivery, zero-touch deployment. So you're not going to tinker around with your GUIs. You have to script it all. We have certain tools for that. So that at the press of a button, you can deploy your entire cluster and everything around it. So when your friendly salesperson says, oh, we have this tool here which allows you to configure security, to configure authorization, and you just click it all together, then our first question is, and does it have an API? Can we script it? Well, luckily we can. So that is the administration layer. Authentication. Well, the answer to the question of authentication in Hadoop is Kerberos. Kerberos has been around for, I don't know, many years. It's an old protocol. It gives you the authentication, so the way to prove to prove who you are. You can think of Kerberos as a way to get tickets to certain events. And the way Kerberos does that is you first need to get a so-called ticket granting ticket. So your ticket buying process is a double thing. It's like you go to the registration desk downstairs and you say, I'm a visitor of the Hadoop Summit. Then the person says, can I see your ID? So the ID is the ticket granting ticket, because based on that, they know, okay, so this is Helmar Becker. And then they check, oh, I have Helmar Becker here in my list, so I will give Helmar Becker a badge for the event. And that is then the ticket to the individual service that you're using. That is how Kerberos works. And you need a so-called KDC, a Kerberos server, typically 2 of them because it needs to be highly available, inside your cluster. What we did at first was setting up one of these services for every cluster that we are running in every project. However, we are now looking at the possibility to share our Kerberos infrastructure among servers. Next thing is to prove who you are. Okay, so Kerberos must have some idea of who is known to Kerberos. You can configure that all manually, but you don't want to do that in an enterprise with 50,000 users. When you have already typically a directory of all your users, which is, in our case, in Active Directory, Microsoft Active Directory. And Microsoft Active Directory is basically a Kerberos server plus an LDAP directory, all bundled together, and some Microsoft secret sauce around it. So that's how you can say it in a simplified way. So we want to have a so-called trust, which says that anybody who is known to the Active Directory will also be accepted as a legitimate user by Kerberos. We have done that. What we did back then in our last deployments, however, was we kept this separate from the Linux operating system users, which are maintained by another system in ING. But this is one learning. We will probably do it a little bit different in the future. Okay, so now imagine you have proven who you are. Basically, any employee of ING is known to Active Directory, so they can get a ticket saying that, yes, you are known to the Kerberos service, but not everybody is allowed to access data in there. So we need to also do something about authorization. So we need to lock down permissions. And well, you could do it based on users, but actually, ideally, you want to do it based on groups and roles, so that you say anybody who enters the company or leaves the company or changes teams within the company will automatically be granted and revoked the appropriate permissions. In Hadoop, you can do that with HDFS ACLs. That is, I know there are teams out there that like this. We don't like it because you have to just script it all together. It is difficult to maintain, and well, it gives you access rules on the file system level for a whole file. But we want to have something that works with all services. So we want to secure the HDFS layer. We want to secure Hive and HBase and Spark and all that. And, well, enter the solution, which is Apache Ranger. It is a good concept. It is not perfect yet. It is, in some aspects, not quite enterprise ready yet, but the concept is good, which says we can configure repositories in Ranger. Each Hadoop service has a plugin that will recognize access control lists that are pushed by Ranger, and you can configure this through an API. Plus, in Ranger, you can assign certain policies to groups that you can get from your Active Directory. There are still some quirks around Ranger, like if you give access on a file system level to somebody, then you can, in older versions of Ranger, not take it back. In newer versions, you can, although maybe you don't want to go that way. So one best practice that we learned from this part is on the file system level, you have to lock down your permission. You just introduce your service users, and then you set up your permissions in Ranger on group level, and synchronize these groups with Active Directory. Also important, at that point, we found we have service users and we've got personal users. Personal users come from the Active Directory. Service users come from the lower level, so they are currently put directly into Kerberos. This is the architecture that we built in the Netherlands. So here you see Ranger. Ranger gets user and group information from Active Directory. Kerberos accepts authentication tickets from Active Directory. So we have got two arrows here to the same box, but actually these are very different protocols. It's important to know. This here is Kerberos, this here is LDAP, so it's actually a directory query. And this is completely decoupled from operating system security. This here is done in our case by a custom script, and I have a slide after this that explains why we did it that way and how we are going to do it in the future. We had a couple of challenges that we encountered on that way, because this here, this red line here, is not so much a technological boundary. It actually marks an organizational boundary. So we've got DevOps application teams on this side, we've got infra teams on that side, and it was a lot of learning and communication to do to bring these teams together, work together, find a common language, and you can still find some quirks in our current setup that reflect this organizational separation. Hadoop users are decoupled from operating system users in this case. And unfortunately, user IDs also are not aligned, and that has some not so nice consequences, particularly when it comes to Yarn users, where you have to bend over backwards in order to run your Yarn containers, because for those you need OS users. Hadoop group mapping also needs some configuration in that case. And so we tried at some point, we just saw, okay, well, it is okay, but we can do better. With the user synchronization, so I said before, we need to get our users and groups from LDAP, because Kerberos in itself just says, this is Helmar Becker. Kerberos doesn't know anything about my privileges. The original approach that the Apache Ranger project had in Ranger was to make a complete copy of your Active Directory, well, say, of a part of your Active Directory. Now, we have a pretty large Active Directory, and if a process comes along and makes a copy every so often, then that creates loads on the network, load on the LDAP server, and bloated directories that we have to mirror, and we don't like that. We also noticed that it improved in Ranger 0.5, because in 0.5 you can say, okay, everybody who is in a certain group is allowed to go on, or it will be synchronized. However, this would limit the replication load, but it is still an expensive query on the LDAP server. So we actually wrote a script that reformulates the queries we do on LDAP so that we really get only the bits of data that we need. This is something that is going to improve a lot in newer Ranger versions, but honestly, what we are going to do in the future is move away from that LDAP query at all. There are a few reasons. One is we have an API here, so we can update our users and groups using API calls, but it's not documented, it's not officially supported, so you're pretty much on your own with it. The Apache Ranger database schema is a little bit, we don't quite like it. It creates duplicate records with group mappings, and all of a sudden your database blows up. And we have that problem with OS integration. So we try to find a better way. And we did that by bringing together quite some bright heads in the community. And we are working on this also very closely with Hortonworks. So this is our new concept. We will have the Active Directory in the background, but we are going to put a layer of IPA. So IPA, what's IPA? IPA is a Red Hat product. Basically, it bundles LDAP and Kerberos. So it's like the Active Directory of Linux. We want to have a IPA layer that handles identity management across all our Hadoop systems. And I think we will soon start, one of our organizations will start with the first prototypes for that. So, an IPA will make all its users known to the operating system via SSSD, and then we use Apache Ranger to synchronize the Ranger, so that is the Hadoop user database, with what is known to the OS. So that way, what the OS knows and what Hadoop knows is always in sync. And the way it goes is like this. So a user is created here. It's created by HR backend systems, so there are people who can assign roles to users and give them permissions in here. So this goes over here, so there is a one-way trust. There's also synchronization. From there, it goes via SSSD. It is published to the operating system level, and from there, it is moved to Hadoop. We've got one team that is very active in committing changes to the Hadoop ecosystem in order to support that better. Especially what we needed and what we are now going to get in one of the next releases is that this here, which used to be just a file-based user synchronization, so basically you go to the etc passwd, instead uses the system calls which honor the presence of SSSD. We will also have to do some changes in our own organizations because certain parts of our current tooling do not readily allow this path to be taken. And we have to still do some evangelization there, but in our next generation setup, this will not be a problem anymore. We are also working very closely with Hortonworks, which also means we are pushing to get these things into the product. And I think of those 4 Jira items that are listed, 3 have already been accepted, 1 is still in the queue, but I just hope that we can get this as fast as possible. There's a lot of more details to this, so this is just a high-level overview. We have discussed a lot of questions like, okay, if you have a central identity management for all things Hadoop, then what happens if somewhere in, I don't know, one of your Hadoop clusters all of a sudden runs crazy and starts bombing your identity management layer with queries, which is going to happen because every service, every communication inside the cluster, everything is Kerberos secured. So every service that is doing anything is going to request a ticket from this layer. So if anything runs crazy, it means we need to have here a segmentation, maybe a DNS segmentation. So we've got several segments that share the same identity management data, but each segment only answers to a certain segment of your Hadoop landscape. Another challenge is that this here is just nicely drawn as one Active Directory. We are still building that kind of structure. I don't know how much may I tell about that, but currently we have a much more complex tree structure. So this is not just a one-way trust. We will have transitive trusts here and also multi-hop synchronizations. But all these questions have been tackled, and I think in the near future there's more to come and probably a lot more stories to tell. That's my story, and yeah, almost exactly 30 minutes. I'm open for questions. I have a nice microphone. Who's first? I think you? Or? No. Yeah, this works.
Thank you. What's your opinion? Is it possible to realize enterprise ready security without customizations as you are doing? I mean, only using Kerberos, Ranger, and all the normal tools.
It depends on how strict your requirements on enterprise security are. I realized that we as ING, being a bank and being a complex organization, both of this, we have probably much stricter requirements than most other Hadoop users. So depending on your use case, you might be good with the tools out of the box.
Thank you.
Hi. How do you deal with things that are not handled by Ranger, like Spark or Flink, or you?
I think Spark is going to be under Ranger control very soon, and Flink, well, we are just looking at Flink, but we are not really using it, and I hope that by the time we are using it, it will also be integrated in security.
Is Ranger a new spot in all the organization?
Pardon?
Do you have high availability for Ranger?
We do not have high availability for Ranger. Because the way that Ranger works is you've got the Ranger admin and user sync service, which runs on one machine. And then you've got the Ranger plugins, which are, well, actually they're just jar files that are integrated in the running Hadoop services. And they keep a cache of the policies. So each machine in your cluster basically knows who is allowed to do what. And they are synchronized with the central server on a regular basis. That means that if your central server, your Ranger admin server, falls over, your cluster will continue to work. You just cannot change anything about the policies anymore.
And with APA, do you use the DNS round robin? Or do you use an external DNS round robin?
Well, I know that currently we have an external DNS round robin for Active Directory, and I think we will also be using that for other services.
Hi. Do you plan to implement security check for implementing the EU data privacy regulation, on which you need to store the consent of the user for specific data and intent of analytics for the jobs?
I'm pretty sure this is already being stored.
And do you know how it is made, that check? It is, you have implemented by yourself, it's used metadata? Do you have any information about how it is implemented?
I don't know the details about that, I'm sorry. So I'm not really in that concrete team that does that work.
You said you have integrated the Active Directory with the Linux MIT KDC.
Yeah.
Was it very challenging, and why, please?
Well, I tend to put it that way. Kerberos is, and building Kerberos trust is easy once you've understood how to do it. However, the way there, it's quite a nasty learning curve. And I think part of this is because the available documentation has mostly been written by people who do not care too much about mere mortals. But once you figure it out, the concepts behind it are actually pretty clear. And what we did is we took a while to wrap our heads around these things. And why is this and how is this working? And in the end, we just distilled it all together into one Kerberos Essentials page on our community pages, so that future generations will hopefully have an easier way to implement Kerberos.
Sorry. Yeah. Two questions.
Yeah.
One question, do you plan to integrate Atlas in your...
Yes, we are planning to integrate Atlas, but we are currently also at a point where we feel that Atlas is not very mature yet.
Okay, yeah, it's a very early stage. Second question, maybe I got your approach wrong, but my understanding is now that all the application users must be known to the operating system. Is that true, or did I get it wrong?
In our previous approach, that was not the case. In the approach that we are going to do with IPA, everybody who does something on the cluster will also be announced via SSSD to the operating system. So we will not write them into etc passwd, but they will be known as, so they will also be valid Linux user IDs, so to say. And the reason that is so is because it's in the design specifically of Yarn that you want to have this.
I'm just interested about the effort you put into this. How many teams did really work on it, and how long really was this journey like this?
It's very difficult for me to put a ballpark figure on this, but a lot of work went into it. And what we also noticed is that that was really one thing where we found that in different countries, different teams had worked on it. Each of them had really strong results in a particular area, and we found it immensely valuable to bring all these teams together to the table and see what are the best parts of each solution, so that we can build a better solution that can work for everyone.
Hi. As part of your global security design, did you think of using a cluster in the cloud?
Cluster in the public cloud is a no-go for us. We are building a private cloud which is running into our own data, running in our own data centers.
Okay.
Hi. You said at the beginning that the cluster is firewalled. Was there a specific reason for that, or are all your main internal systems firewalled?
First of all, firewalls are generally there, so even in batch systems. The reason our first analytics clusters were completely locked off is because, it's also part historical reasons. Nowadays, pretty much everybody recognizes that putting Kerberos on top of Hadoop is kind of compulsory best practice. When we started our Hadoop journey about 3 years ago, Kerberos support for Hadoop was very poor. Hortonworks support for Kerberos was very poor. Nobody really knew how to do it, and in order to get started, we are also agile, so in order to get started, when you can't secure it internally, then your best bet is you put a big firewall around it all.
From a broader sense, do you think vendor lock-in is going to be an issue coming up in the future, like when you have things like Atlas and Ranger versus Sentry and Navigator and that kind of stuff? Maybe not like you're running a lot of custom code, but say for slightly smaller vendors, do you think vendor lock-in is going to be an issue?
There are not that many vendors in the area, right? And the good thing is it's all open source, so even if we change the vendor, we can still maintain our existing solutions, at least for a certain time. We also know that, for example, Atlas is not only supported by Hortonworks. Actually, there are big players like IBM in the industry that have a much bigger vision for Atlas, which makes a lot of sense because enterprise-wide metadata management is a big thing. And I didn't tell a lot about metadata management here because that would be a whole other talk again. But yes, of course we hope that the tools that we use gain traction in the community, because then we will find support for them beyond one single vendor. See, for example, Spark. There's a lot of people out there that can support Spark.
One last question, maybe?
Just one. Amberry integration with IPA. Is Amberry able to integrate with IPA?
Right now what we would do is Ambari integrates with LDAP, and IPA has LDAP, so yes, it integrates. What we would like to see is that Ambari would integrate with Ranger, so that it would all boil down to our SSSD integration, and that is currently not the case. So I asked the very same question to Hortonworks, I think the day before yesterday, and it's some homework for them to do. Yeah, I think we are running out of time, so then thanks a lot for coming, and enjoy the rest of the conference.